Yeah. So I made a small slides, several slides to introduce the Geoweaver, and I will do some live demo. But this is still a prototype tool, and although we have used it to generate a lot of products on our server, but you have to be very familiar with the Geoweaver right now. So we are still developing this tool, and it's really helping. I mean, I'm using this tool every day, so it's quite helping. And I hope that and everybody else can benefit from this tool. So,
thanks, Ziheng. I'll just also give a quick introduction that that we're really grateful that you came to Waterhackweek to give this tutorial for us, and that, you know, to acknowledge that you and I met at an ESIP. We had an ESIP funding for the ESIP Hub funding at the,
ESIP
on the
Lab,
same year.
ESIP Lab funding.
ESIP Lab funding, and
yeah.
Yes, and I remember seeing early. I think that's where this started getting funding. Also, how I connected with you. So I just wanted to give that shout out to ESIP as connecting us. And then the early versions that you were showing me when we met at that winter meeting in 2018, I'm really excited to see what this turns into. And if you like, what I'll do is turn off the video, or I can keep my video on, but I'll mute. And then we'll have questions at the end, if anyone comes in, or Jill, if you have any.
Thanks. Oh, actually, to start, could you tell, just give a brief overview of the type of work that you do with this? Or it might be in your presentation too. I was just.
Yeah, it's it will mention a little bit about the technical details, and most of them will be about how to use it and the function that is available right now.
Ziheng, when we first met, I'm not going to get this exactly right, but you were presenting Geoweaver as something along the lines of, there's all this data, crop pictures and photos and remote sensing data of land cover and crops, and you wanted to create a workflow to make that easier for AI.
Mm-hmm.
And I don't remember, I think maybe, is that the still how you're applying Geoweaver? Or you can, or maybe just bring up, or give us an overview of your original motivation for developing it, and what the current sort of user applications or outcomes and types of data you work with.
That's a very good question. So the first motivation is organization. So most people do their research on one laptop, right? Everybody has one laptop, and it's easy to install everything on that. But what if you have two, and one at the office, one at home, and what if you have three? Okay, so one computer with GPU, the other one doesn't have the GPU, but you have code on that. What if you have five? Five is me, right? I have 5 computers at home. How do you manage all those computers? Like simply remembering which file, which software is installed on which computer is impossible, right? I don't know if you have the similar experiences before, but I have a lot of painful experience like that. I have too many computers. I have to install all the environments, Python environments, libraries, tools on every single of them. Although I have 5 personal computers, actually I'm managing tens of, actually 12 servers located in George Mason campus in the data center. So is there any easier way to manage those things to make make the whole workflow? Imagine that you have an AI workflow deriving all the watersheds from the remote sensing data. And you want to do all these experiments on one server, but the data is too big. And you want to, maybe I need a subset to test the models, make sure the model is working train the model first somewhere. So I use a new server, a new computer to do that. And then I have to repeat the whole thing again. So that is a huge workload for everyone. I think everyone is experiencing the same thing if you want to do that kind of work. So so Emma always asking me about these questions. What if you have a GPU web server, a EC2 instances on the Amazon Web Services, or GCP, Google Cloud Platform, TPU instance for the artificial intelligence model training? So how do you conduct your research efficiently? How do you manage those things? And that's a very big question. Actually, there is no solution on the market right now. Surprising, right? There is no solution managing all the hybrid resources, including your private computers, your purchased cloud instances, your institutional servers. No solution to manage all of them in one place. So everybody is working like this. So everybody is using several computers, using a lot of screens hanging on the wall, and looking all these, probably it's really painful to remember those things, like which file is on which server, which server has what kind of environment. In the Python environment, has a lot of libraries. Which library is required for this kind of scripts to run? That is a lot of things to remember. Actually, I cannot remember anything like that. Even I write some notes about it, I will always forget where the note is. So that's a problem. Actually, that's a real problem in the reality. And I think a lot of people saying the organization is a key to access, and disorganization probably is a career killer, right? For all those AI scientists, for the earth scientists, water scientists, hydrologists, how can they manage all of this? Everybody is facing the same problem, as there is no tool to solve this problem, organization problem about the hybrid workflow to processing those data. So that is some blank space in the market, actually. Nobody is thinking about it because everybody knows that is tough, difficult to achieve. So that's.
Can I interrupt with a question about the one thing we're trying to do here at Waterhackweek is grab the vocabulary that is words that sound like you think you know what it is, but maybe you don't. And I wanted to ask, by hybrid workflow, what do you mean by that exactly in this context? And I'll try to capture
hybrid
that definition of it.
Yeah, that's a very good question. Hybrid workflow means the workflow runs on distributed resources, and those resources are hybrid. Like the private laptops, institutional servers, and the cloud instances, Google S Engine, and notebooks, distributed notebooks, and the Colab. If you know the Google Colab, that is also another kind of notebooks, very similar to distributed notebook, but it's called Colab. They have their own API. And also there is many web services like the OGC web services, the global, the data transfer services, and all these resources are different. And if you want to change them into one workflow, that workflow is called hybrid workflow. Is that clear? I hope I can explain this kind of concept clear, because the hybrid workflow is pretty novel. That's right. Actually, I think before me, nobody called this workflow hybrid. That's something I invented, actually.
Well, okay, well, I want to make sure to give you credit. So at the bottom of the notes page in Kiko chat, I'll try to capture what you just said, and you can can carry on and all, but we'll
Okay.
catch up after.
Great. So yes, the hybrid workflow management is actually a blank space in the market. So because if you look at those solutions on the market, Amazon has a solution managing their own resources, the EC2 instances. Google has a management tool for their GCP TPU services, right? Nobody is managing both, managing AWS, GCP, private laptops, and institutional servers bought by, probably NASA funding or NSF funding. And especially the supercomputers that is located in all around the United States. So we have access to those resources, but we do not want to repeat all those software installation steps everywhere. We want one tool to manage that for us, to automate those workflows for us. So that's the first motivation of Geoweaver. And the second motivation is history. It's a provenance, because every time we execute the workflow, sometimes the Jupyter notebooks will not record every time the result of every rule. If you run the Jupyter notebook again, you will lost all this history. I would not see the result, because if you change the result names or file names, you will get all those results. But you will lose all the history of the script running. If you want to check, why this result looks like this. If you want to check its source code, it's gone. Actually, it's gone every time when you change the code. So we want to find back those exact source code executed by then, right? So every execution should have a history available for you to query later. But that is not available right now. So if you check, this function is actually essential when we are working with neural networks, because neural networks, every run of the neural network model will generate something different. It's not certain, right? It's uncertain, actually. It's not random, but it's uncertain. So for example, if you get first model training will give you accuracy of 81. The second training of exactly the same model will probably give you 82% of accuracy. But that variance, that difference is not very big between two different runs. But there is always some slightly differences in the probability, accuracy, and errors. So this is especially requiring the function to record all this history and provenance. Because if you don't record those information, we have to run the model millions of times. Probably most of the time are unnecessary. It's a wasting of resources and time. So how can we locate the program when we think it works? We found that, okay, so I have trained this model for 1,000 times, and finally I got some working model. But that model has to be locked, has to be located by some mechanism. We have to replicate the whole process, even by somebody else. So the result can be acknowledged by the whole community. But one problem is, how can we compare the two execution results together with the corresponding source code? That's actually another problem that is unsolved by the software on the market. So this is a second motivation that we have to develop this software called Geoweaver. We want to record the history of every run of the software, of the script, Python code, Jupyter Notebook, and probably some other programs like R or built-in processes. And another feature we want to implement is the hybrid workflow management. So in brief, introduction is Geoweaver is a web-based workflow management system. So it's ideal for hybrid AI workflows on distributed platforms. So if you are working on one single laptop, it's not very necessary to use it unless you want to record all this history. Otherwise, it's not necessary to use Geoweaver. If you are managing multiple resources, if you are for example, if you're managing a cloud instance, if you are managing a Google Cloud Platform resources instance, probably you are managing tens of thousands instances on there. If you have S3 basket, or if you have some servers that you manage in your campus, that is purchased by the NSF funding or NASA funding, probably you should install Geoweaver to help you to manage them. That will give you a lot of free of hands functions that you can manage all those files. You have a clear sense about where the files is and where the source code can be executed, because source code is only stored in the Geoweaver database and it can be run anywhere. You do not have to worry about all those libraries environment. Just store the source code, write the source code in Geoweaver and run it everywhere. So that's the ultimate goal of this workflow web management system. And it's open sourced. The license is MIT. So anybody can use it, even the commercial companies can use it, or they can redistribute it or develop based on this software. And it has a very user-friendly graphic interfaces. Actually, very important feature of this one is it has FTP, SSH, and WebSocket features. That means that you can access files through the Geoweaver, even that server is not accessible from your laptop. For example, if you have some servers behind your university's firewall, you can install the Geoweaver on some proxy server and then use the Geoweaver interface. You can access those the servers behind the firewall without without proxy or without VPN something. So it's kind of like a VPN alternative. It will give you a lot of convenience like that. That's why I'm using this Geoweaver every day, because I have a lot of maybe terabytes of files on the servers. I have to access them every day. Now it supports the Shell, Python, and Jupyter Notebook. Jupyter Notebook is still in the experimental phase, but we are having some breakthroughs this month. So next month. So I expect this will be available this year. So this is a demo video. Later I will give you a live demo, but this is basically how the Geoweaver looks like. You can see that you can run the process in the workspace on the left, and all this code is editable. You can edit it and check all this history by clicking that button, and the history will display in a chart, and it will show you how many times of execution on that day. And if you click on the details button in the history table, you will be able to look at. You'll be able to access the source code executed at that time and the output log of the execution. So Geoweaver do not record the actual result files. So for example, if your Python scripts generate some data files, generate some data files. The file is on the server. It's not on Geoweaver. Geoweaver only stores the source code and the logs. like this. So, so the reason to do that because we hide the data flow. The data is too big to store in the Geoweaver, and that's something that we cannot do. Just to store all the semi-finished product in the database is impossible. So we only store the log, the log out of the workflow execution. So that's basically how the process works. And later I will show you how the host works. It has 3 types of resources. So first level of resource is host. Host means a platform. Like if you have a physical machine, a laptop is host, a desktop is host, a server, AWS instance, and a workstation, supercomputer, it all is a host. So we manage all these resources as one type of thing. So every single platform is a host. And to access the host, we will integrate all these APIs. For example, if you want to access the Linux server, we will use the SSH, so secure shell, to access it. So everybody is using a secure shell, and Geoweaver will do the same. So it will feel exactly the same while you are operating on the system. It's just like changing the environment from your command line to the Geoweaver command line. And the second level of resources is the process. The process will be run on the host. No matter which host, just the process will be run on the host. The process includes the shell, the Python, Jupyter notebooks, and something, and all the other types of the source code. The workflow will be a linked chain of the processes. So it will automate your workflow for you. It's like, for example, the AI workflow. It has the data pre-processing, the model training, the model testing, validation, and the model results post-processing. So the 5 steps can be automated by the workflow. You can chain all those processes. If you have those processes available in Geoweaver, just link them in the waiver section. There is a waiver panel, and you just link them by drawing lines between those nodes. And after you collect them, it will be a workflow. It's kind of like a drag and a drop workflow component. It's very easy to use. Okay, so how the Geoweaver can meet the assigned needs. So first, we can integrate the public and private resources. Like this one is the server. This one is the server I manage. This is the server room, the data center managed by the George Mason on the campus. It's on the campus. It has a lot of advanced facilities there, but it's not a supercomputer. That's all those servers there is a university property. And we also tested on the Amazon Web Services, the EC2 instances, and it works very well. The Google Search Engine is something ongoing work because we want to integrate, let people to execute their Google Search Engine script in Geoweaver, and that's very awesome feature. I think if it works, it will attract a lot of people because in Google Search Engine, nobody can change their scripts together. And in the Google Search, you can only work on their script once at a time. And if you want to change the whole processes, that probably is impossible because Google Search Engine do not support the AI modeling right now. It only supports some basic machine learning models like random forest, SVM, and decision tree, but it does not support TensorFlow in the Google Search Engine because the Google Search Engine people said you can only use the TensorFlow through the Colab. Colab means you have to download the data from the Google Search Engine, process in the Colab, and then send the results back to the Google Search Engine. So the actual AI work, AI job is done in the Colab. So if we can create some workflow in the Geoweaver, we can link the Google Earth Engine with the Colab and make it automatically done with all the provenance recording. That will be a very useful tool for everybody. And the second feature is we can record every run of the AI workflow, just as I demonstrated. And third feature is if we are adopting Geoweaver, we will have a capability to synchronize all the source code across the platforms. So we do not, we have the EC2 instances and the Google Cloud and Azure instances, and we have the same Jupyter notebooks on them. If we are using Geoweaver, we do not have to change them one by one. One change and apply to all the platforms. So we only change once in the Geoweaver, and that's it. So that will be another major feature of Geoweaver: synchronize the source code. And the fourth feature of the Geoweaver is we will automate the AI production workflows. As we know that because my background is a remote sensing scientist. Actually, I have worked on some water body extraction before. That cover classification. Water body is always a very difficult part. And the data we processed is the NASA Earth science data. That data is huge. It's like because it has a very long time series. The MODIS data it has 20 years now. It started from 2000 or 2001, I think. And to process those data, we have to take advantage of those big data processing platform, like the Google Earth Engine, like Amazon Web Services. So how to automate those AI production workflows? For example, we want to generate the water body map, water body products from 2000 to now, bi-weekly products. How should we do that, right? We cannot do that on any single servers. We cannot, because the data is huge. We cannot do that on laptop. We have to make use of those existing resources like this one, and we want to link them together. And how to do that? I think Geoweaver will be a very good solution for that if we have all these features are available. And this is our vision of the workflow managed AI. If we manage all those AI models through the Geoweaver, what will happen, right? What the benefit we got? So first of the benefit is the efficient AI engineering. AI engineering is not like a physical modeling. It's because of its uncertainty. The AI engineering is super slow. Because every time we got something different. And one of the major problem is we do not remember what we did before. If we have all those provenance available, that will reduce a lot of unnecessary training and testing. If people got a code, for example, I trained a model and Christina got the model and Christina wants to test it and she will train it again. That is absolutely avoidable, I think. If we have those provenance, Christina can see all the model training history through the Geoweaver. And that will make the AI engineering more efficient among people, among institutions. That's one of the bigger vision we have. That if the adoption of a Geoweaver will save a lot of time and money and workloads. And the second is a traceable and explainable as AI models. Because we stored all this history, the models will be traceable and probably it could be explainable because the weights in the AI models. In the trained AI models, it's explain them is very difficult. We can compare the model with the traditional models and see why it works like this way, like why this model can recognize the water from from the forest. So we can see how all those thresholds it used. Probably we can explain why the model works. And the third feature is that lower workload on both personal and machines, because we have all those histories, so we do not have to run it every time. And then we have the shared knowledge, because the workflow, the processes in the Geoweaver, they can be shared through the, there is a button that you can share with anybody. And probably you can also download those scripts and workflows in a package. The package will contain everything. That is customizable. You can contain some history, or you can remove those histories and just download the code and share with, send it to email it to somebody else. That is a shareable knowledge and reproducible workflow. So yeah, so that's the conclusion. I think I spent too much time on the presentation. This is some links. Then this is a support we supported by the ECIP lab and Geoinformatics program award that we have applied together with the eScience Institute. I think Nicolate, right? And also this work is supported by the SGCI. They provide the consultant services for marketing and development years, and also AGU. So I will show you how the workflow, how this system works. Yeah, I only
while we watch you do that, Zheng, I just want to give Jill a chance in the next 4 or 5 minutes to ask any questions that she had while you're doing the demo.
Where is the questions?
Oh, I think I'm the only one on besides Christina. Sorry. So she's.
Okay.
Well, we'll have questions also on later when people watch the video. So if there's something you want to capture now, Jill, you can. Otherwise, we can. This tutorial is going to be on YouTube and on HydroShare. We've got an archive, and we'll link it to the learning resources. So, learning resources, GitHub issues, like wherever you want to be contacted, Ziheng, with more questions, like, let us know. Otherwise, we'll put it in the Slack channel and the Ether notes for Waterhackweek. Or Jill could ask live now. I guess
because I'm not a geologist, I'm in public health, and I was interested in this because we were looking at applications for looking at neural networks to look at antimicrobial resistance. So this is an application that can be used for a lot of different tools if you're pulling in. Is that correct? It's not just.
Yeah. Actually, what the use case I want to demonstrate is diabetes.
Oh, great.
Yeah. So.
Well, we should let you do that. And
thank you.
Before I interrupt, my use case what I think is so great about the tool, Ziheng, is the same workflow problems with the diabetes data or health data is kind of the same problem with getting local, like co-op station data or real-time observations of extreme events, because it's a discrete unit of time, and you've got to go out and scrape it and go. There's always some adjustment, so you're on a hybrid workflow with distributed ownership issues, which is similar to the health data set. So I think this is has amazingly powerful and really useful gap. So thank you for all of your work. I'll let you demo it.
Okay. Yeah. Okay. So regarding the Jill's question, this tool is initially designed for earth science, but I think it can be used for every domain because it does not have domain-specific requirements. All these tools are basically the universal. It's kind of like a Jupyter notebook. It can be used by the public health, the geology, water science, hydrology, earth science, anybody actually. So as long as you have your Python script, you are working with Python, working with Shell, working with Linux, this tool should be work for you. So I'm gonna demo this this neural network based on the data from the diabetes. Actually, I should have found some water body data, but I didn't find it. Actually, I'm trying to use some source code from Hydro here. And I found that it requires some environment like this one. It requires some environment. Say this library is not installed, you have to install it first. So this is some point, some problem I'm talking about. So we want to manage all those environments through the Geoweaver. So if we found that the library is not installed and that we have the permission to install the library, we can install it for you. So that would be a very efficient, convenient feature in future. And I'm gonna run this. I think it's already running on my local machine, and you can see all these histories. So this is yeah, see, so this one is running because I just clicked it, and if you want to stop it, just click stop. It will not bother you anymore. So if you want to check the history of this script, you just click it here, and you will see that the results, the overall accuracy is 77. It's not very good. I think this case can be found on the link. I closed the link. This is actually a very basic neural network application, just a prediction of the diabetes among people, among the Indians. And the training data set and the testing data set are in the same CS way. So it used I think it used 80% as the training and 1% as testing. And the epochs is 150. So if we do not satisfied with the results, we can edit the click edit the code and then run it again. Just like that. Okay, so this one is finished. Okay, so let's see. The old code is probably I need to refresh the tool. Anyway, it's I actually want to demonstrate this one. So once your code is finished, like your model is executed, if you want to check out your files, just click here, because the host there is a server here, just click this one, enter your SSH password, because Geoweaver doesn't store your password, that just pass it to the server, so there is no security problem. Oh, this is my, okay. So this is my local machine. So you have to ensure that you have your internet is accessible to the target machine. Otherwise, it won't let you pass through. Okay, so all of these files are generated by AI models. This is an agriculture map. It's a net cover classification. And after my model is finished, I just click this one and then I will see the results. Yeah, so this is the one thing of that set, and the yellow is the corn. And this blue thing, this blue one is a water body. I think it's a lake or it's a dam. This is absolutely a dam.
Okay, this is what I wanted to see when I started. This is how we should start every tutorial for Geoweaver.
Yeah. Okay, I should move this part to the first at the very beginning, right?
I know that's not your style. You're very, you know, you want to explain all of the, you know, how it works so that everyone understands where it comes from, which is important. But this is this gives me a really good idea. I don't know how you feel, Jill, but I was like, oh, this is what he's trying to do.
Mm-hmm.
You can have it at the beginning and then bring it back at the end, too.
Yeah.
Yeah, I should have asked all that.
But this is great. Do you mind if I wrap us up here too, unless there's other pressing questions that should be recorded? We can do more recording later.
Okay.
Or a final thing you want to show on the demo.
That's all I have right now. Actually, you can upload
Okay.
well. So upload the SSH and all those buttons are all useful. So you can operate on the host level, process level, and workflow level. Workflow is kind of like this one.
Mm-hmm.
You can join it on here. You can collect more processes into your workflow, like this one. And you can press Shift and collect with this one, and then that's a new workflow. You can execute it by clicking this button. So all these processes will be executed based on the order you specified. So it's pretty simple, I think.
Jane, thank you so much. Jill, do you have any other questions about looking, you know, from getting a view of the map? Or I know my question is about scheduling. If we can look at Geoweaver, like the example of getting Geoweaver working with a National Water Model notebook that I've got running from GitHub that also runs as a team project on the Waterhackweek Jupyter Hub, and also could run on different, you know, how would we build a Geoweaver with an example from our current team project for COVID-19, for example? If you could help us understand that maybe later, whenever you're available later today, would be
Sure, I want to look at that project idea. Actually, I'm not very familiar with what the project trying to do. I think yeah, I'm more interested in how the climate and water use impacting the COVID-19.
Okay.
Probably
That's the workflow I'm
case.
trying to build. Yeah. Do you have any questions, Jill?
Yeah, just one. Are you able to pull R into this as well?
R is on the schedule, and it's not available yet.
Okay, that's great though. Mm-hmm. Excellent work.
Thanks.
Yeah, I'm just going to wrap it up and say thank you, Ziheng. I think this is I think you should get ready to be super promoted by me as much as far as I can as being a geo-health research superhero, because this is exactly what we need to be able to manage privacy and governance between like spatial aggregations and different levels of data protection. And the workflow is always going to get broken up like this. And I always struggle with this problem, even with the smallest, you know, to go from an academic modeling example of a research paper and reproducing that model is a totally different thing than trying to reproduce a model that uses government data that you've developed the model with a government agency who has data restrictions for storage or for browser or for just runtime or working with their scientists. And then to tackle the next layer of data sensitivity from disasters and health records that have implications for all of us and for public health is, it's a big gap that you're filling. So, and you're probably not aware of how huge those shoes are, or maybe you are, but thanks for helping pioneer.
That sounds a very big project, but I will try. Yeah, at least we can help some basic requirements. Like if you have those public health, I know the servers in the public health fields have very strict security measures. So this tool is actually can help you to actually uphold those measures, because all these resources are protected by password. So it's not means that everybody, if even they have the access to the code, they cannot have the free access to the host. So it's kind of like even somebody else saw this platform, if you publish the process, but your resources are secure. Yeah, that's something that I can only imagine, and I can only think about at this time. Probably there are more, features, there are more things that we can do with this tool.